speaker. Although he doesn't need any introduction to many of people working in this area. Yeah.
Yeah, that's what I was going to do. Okay. So, sir, welcome to this FD program. And I got this opportunity to just because I can't go and your entire achievement because I know that it is a huge. So I will try to sort it. And if any mistake, please excuse me because it is our duty that to let the participants to know exactly to whom they are listening. And some of them, I hope most of them already know you. And but still, I will just go through your short biodata. And Professor Kotnala got his PhD from IIT Delhi. Then he has achieved lots of award like Raja Raman Fellow, DAE, that is to advise on magnetic measurement on ICAL detector of Indian Neutrino Observatory, INO, mega multinational project bigger than Sun project. That was around rupees 15 billion as Raman Raja Raman Fellow. Sorry, I just it's okay.
Raja Ramanna fellow.
And yeah. He has published more than 500 research papers with over 11,000 citations. That itself shows that credentiality of the SARS in the research and development. It is not the only the achievement, and his H index also more than 50 as per the Google Scholar, and also the H index 43 in ACI peer reviewed journals by Google, that is more than 1,000 citation in 6 months. So that was in the 2020, that was his achievement. And also he is having 11 patents, USA and India. And he has industrial consultancies also, and he has published 4 books and 8 book chapters. And in the last few years, I can say that in the very good number of years, he is working on hydroelectric cell invention. That was his big achievement. And there are lots of YouTube video and also the internet documents. And I hope any participant wants, they can go through. Sir has given lots of invention and the contribution to the country. And so it was written that unbelievable path-breaking invention of water splitting to generate green electricity by hydroelectric cell, and that was one of the pride for India. And it was also highlighted in the ministry in different forum. And right now, Sari is holding this position. You can see chairman NABL, and that is a big position, and he is holding, and it is very busy, but still when I request and he agreed that to address to the our gathering. And thank you very much, sir. And hello.
Yeah, you are audible.
No, I want to see that sir is hearing or not. Thank you very much, sir, for accepting our invitation. And really, we are grateful to you. And I think I will not extend more because although there are the lots of means your achievement, and briefly only I will just tell and hand over to you. That is that, sir, Sigma XI elected member as an exceptional contributor to the research community, the Scientific Research Board Honored Society USA, world's largest honored society for scientists and engineers, and Raja Raman Fellow DAE already I told. Then he's the associate editor of Journal of Applied Physics and IIT Science Measurement and Technology London, UK. And earlier he has held several positions. And I will not take much time, sir, in between you and the audience. I hope if anybody wants to see such achievement and if he wants to know something, and only beauty, I will tell that he is very cordial, and he calls the university students even and without bothering that whatever it is, he called them to the Delhi, and I know that he is teaching them and how you can do the experiment. And this is nice of you, sir. So we are very happy that you are with us and enlightening to the student. Thank you, sir. It is over to you.
Uh, Dr. Manoranjan Kar, thank you very much for the getting me the opportunity for to speak with the faculty, particularly that how they can develop their initial career. And in this case, I am really thankful not only to IIT Patna, but also AICT and Dr. Ajay Thakur. So, who has been, conducting and then to all of the faculty members who have joined to listen this, uh, my presentation where I'm going to tell those things which are rarely spoken, because I'm going to speak everything that is what we really need in our scientific career in the beginning, and later how we can make it a global dent. So it is not the only the level that what I feel that we should talk about the national, but we will be talking about the international, which you have briefed very well. Professor Dr. Manoranjan has already briefed about me. That is more than enough to know. But the more things I'll speak with the science, the what we are doing and my experiences, so that these faculties are going to get motivated, inspired, so that uh, the India can flourish in our research and science. So here, for this purpose, I am really thankful to all of the audience also and the other people who have made the arrangement. And now I'll come to the point of what I would like to discuss. So, Dr. Manoranjan, do I have to share the my PPT, or you are sharing it?
Sir, as you like, if you want, I will share, or you can share, sir, so that your control will be better.
Okay, okay, I'll do that. Right.
Yes, sir.
Uh, are you able to see slide?
Yes, sir. Yes, sir.
Yes,
I
sir.
can see.
Okay.
Sir, you can put it in slideshow mode.
I have put in.
Oh, maybe it will take some time. Okay.
Hello, are you able to see?
Yes, we are able to see. However, it is still not in slideshow mode. So while sharing, if we simply share the screen, and then what happens? Many a times there is an issue with PowerPoint compatibility.
Okay.
with sessions. So if you simply share your screen, then whatever you see on your screen, we see at our end. So for this, you may have to unshare and share screen.
चेक करना पड़ेगा. Hello, are you able to see?
Not yet. Yet.
Okay, I'm trying again.
Share desktop screen or some screen. That sort of an option.
Share content.
There are about 4 or 5 options it will give you. So simply clicking on screen, like complete screen or something, that would help. Share and then screen.
It's browse my computer. It comes after that. No, this is not.
So in any case, whatever way you were presenting, that was also visible, except that it was slightly smaller. So that will also do.
Is it now visible? Is it visible?
Really.
Hello?
So not at my end.
Not
Dr.
at your
Kerr,
No,
end.
no,
can you
not yet.
confirm?
No, no.
Is it visible now? Hello?
Not
Not
yet, sir.
really. Not yet.
Not yet.
You want me to share at my end? I will do that. In that case, I will have to be, yeah. So I will try to. You want me to share?
Yes,
There
because
would be slightly less control. Okay, fine. I will do that.
right. Can
I will share it. Just a moment. I hope it is visible to everyone.
I can see.
is it from you and from me?
From my end. It is from my end right
From
now.
your end.
From my end. So like if I right click, I'm able to change the slides. Yeah. So you would like to try again once more, that is fine. So in that case, let me just unshare. Because otherwise, yeah,
Yes,
even you
then
are
it will
sharing
be,
now.
I
Sir,
try
even
it
you
now.
are sharing now. Even you are
Yes,
sharing
now.
now. So just
Yeah.
clicking the full slideshow button at the bottom, that would just help. Just beside the battery
Is it okay?
percentage, so like the 70%, whatever is written, beside that there is a tab at the bottom of the screen. Bottom right, there is this thing called 70%. Just beside that, if you click, Mostly it should be full screen. Otherwise, we can continue it this way, sir. This is also fine.
Because with this, it is not appearing on that one, but this much is, I think, visible to you.
Yeah, this much is quite visible, sir.
Okay,
This is
sir, it
perfectly
is
fine.
fine, sir. You can go ahead, please.
You can go ahead,
Right.
sir. Please.
So let me come to this. Sorry for the sharing time. Uh, the idea for this lecture is to talk about the most, I'll say, astonishing invention of hydroelectric cell based on ferrites and metal oxides, smart green energy materials using water splitting by non-photocatalytic process for sustainability in green electricity and environment for a better life. The title has been kept a very long. This was done purposely because this is not a teaching class. So this itself tells that we are using metal oxide as a green energy materials. This we could do it in our one of the invention in way back 2016 using water splitting, because the on this green energy material which we metal oxide which we have taken up, so they are doing what? Water splitting, water into two ions, H plus and OH ion, and specifically non-photocatalytic process. It means the what we are doing, we are not using any of the light, any radiations, any catalyst, no acid, no alkali, no electrolyte. That shows a non-photocatalytic process. It means it's a very simple. You have got a very small material palette, which just like a solar cell, and it is when the water few drops are put on it, it immediately dissociates into two ions, H plus and OH ion. Now those H plus and OH ion are being collected, first separated, then they collect by the electrochemistry. So that electrochemistry means we have used the two electrodes, which one can see that it is a schematic diagram of our simple hydroelectric cell. Name also we have coined. Working principle we have given. The material is from the India. Everything is from India. And if you look at the grid structure, rather we call it a sublime finger, it is acting as a cathode. Silver is being used as a silver thin film on it. And on the back side of the palette, means the other face, we have put zinc as the anode. So while the water has been split into H plus and OH ion, you can see that the H plus ion goes towards the silver and OH ion goes towards the our zinc. While it happens, so that zinc is released, forming the zinc hydroxide, releasing two electrons, and those two electrons are ultimately arriving to our cathode, and their H plus ion, which has come from here, is taken as the 2H plus 2 electron and generates hydrogen. So the what has been there in the hydroelectric cell, we are not only producing the electricity, because at this stage, even the 1 inch square hydroelectric cell, which is we are using as a magnesium ferrite as a base material, we are getting 0.1 ampere current out of it and 0.98 volt, means approximately 1 volt. So here some of the applications have been shown, and the one can think that we have got an instantaneous device, which is a combination of the material property, means oxygen deficient, and then the nanopores, means the nanoscience we are utilizing. I will explain you later on this issue, what we are doing. So nanopores are used. It means nanoscience is playing a big role into it for our splitting the water into the H plus and OH ion without giving any external energy to it. And finally, what we are getting, that we get a voltage and current. And on that voltage current, about 1 volt I have said, and 0.5 ampere current out of the 1 inch square cell. Besides that, it is its byproduct is the hydrogen gas, which is a very and the zinc hydroxide, which is the another byproduct, which is again a very expensive industrial material, and it has a value for it. And all these are obtained zinc hydroxide powder in the form of nano. So the nano particle, you know very well, they are expensive. So these three things are there. So any byproduct is not at all waste, or it is going to create the our atmosphere into the pollution. So, and no other gas is emitting, which is giving us anything, I'll say, mm, away from this. So that is why the what I had imagined as a it's a abstract of it, the world-class amazing invention of green energy device hydroelectric cell represents the most versatile green energy solution ever invented. Eh, But the question is, it is not that the I say, it is already from the international reputed journals and the other handbooks, they have already accepted it as such. And the news, national, international, on it, on the hydroxyl. It is an exceptional advancement in the development of green energy source, and it has opened a new domain of green and clean energy. The invented new electrical energy device is based on nanoporous and oxygen deficient magnesium ferrite, SNO2, TiO2, pellet, and many more, because we have done already on 27 compounds, which splits water molecules into ions spontaneously at room temperature to generate green electricity. A 1 inch square cell develops a maximum voltage 0.9 volt and a short circuit current of 150 milliampere. But I had told about the 100 milliampere as the our I'll say the peak, not the peak value, but it's the average value. So results are highly comparable to solar cell and other portable electrical energy sources, that too without use of any electrolyte except water. Then once we say that this is the one part, and the which I was just briefing that what it does. So hydroelectric cell operates at room temperature. It does not produce greenhouse gases. It has been fabricated using inexpensive precursors, cheaper than fuel cell and solar cells. Hydroelectric cell technology offers safe, clean, low-cost, reliable power generation to both consumer products and industrial equipment. Among green energy sources, solar and fuel cells technologies are growing fast. These energy sources are expensive and involve tedious manufacturing processes, because the solar and fuel cell are, we are using them, but they are expensive and tedious manufacturing processes also. The important feature of hydrocell is the ability to generate economical electrical energy using simplest technology at cost-effective level compared to other renewable sources. And it has been already accepted, and we are publishing. We have published a lot of work on it. Hydroelectric cell technology offers safe, that way, clean, low cost, and this cell can be used in a wide range of portable, stationary, and transport applications, from battery chargers to low power devices. The utilization of cell for domestic electrical energy needs and as an automotive power source would be a key factor in terms of economy, safety, and easy uses to replace hydro energy based fuel cell, storage batteries, etc. Its uses would significantly reduce urban population because pollution, I'm sorry. So urban pollution is one of the biggest problem, and not only to this, it is with the even our whole world is facing the problem of the our greenhouse gases, the climate change, which we are getting, but because most of them are our energy sources, so those energy sources are to be replaced by our hydroelectric cell. Then the question comes that the how it has been the so much so. So in last 3 years, the recognition of hydrocell, and of course I come with this, and my one of the co-inventor, Dr. Jyotisa, New records created by Hydrocell invention in social media. Over 1.8 million viewers of Hydrocell on YouTube within 3 years. And I have got more, it's a old data, so more than 27,600 followers in LinkedIn. In spite of the, because, getting into a new energy domain and doing this. So I have a first PhD in silicon solar cell from India, means it's IIT Delhi, and authored book R.K. Kotnala NPC, Essential Solar Cell in 1986. It is the first book on solar cell in India, fifth book in the world. Today, 18 PhD scholars are pursuing work on hydrocell for PhD thesis, leaving apart scientists, professors. Already 60 research papers have been published by others. By us, 30 papers in last year. Means you can imagine 46 papers in the reputed journals have been published on hydroelectric cell. So that gives a validation of the what it is being done. Dr. Kotnala supported 137 industries to provide them industrial solution, because this is my another forte where I provide the industrial solutions on ISO 17025, interaction with 70 universities, IITs, published over, it's again old data. I have published already more than 550 research papers in SCI peer reviewed journals, and more than 500 invite talks, H-index, citations, and the patent chapters in international books, handbooks. So if we look at this, that these are the things which have been already achieved, and I have spoken about only the one part, the green energy, green and clean energy device, which has been developed, innovated, invented in India, right? From the indigenous raw materials. Even I'm using the furnaces from the India. Even the ball mills, which I'm using for my practical purpose, is from India. So I would like to convey the message to the our listeners that it is the situation when you work for it, you have to think big and you can do things in India. And anybody can just look at the hydroelectric cell, you just Google, you'll find that we have got this stake. Of course, now the other people have started working, but following us. So that shows the strength of that field. And I always invite the anyone researcher who wishes to do it. I say, okay, please come, give a new idea, work on it, and then we'll do. But do you think that it was possible only by doing the research for the 10 years? No. It has been my 26 years of the research experience in the national lab, definitely, because I have been working in National Physical Laboratory. Even today, I'm delivering you the lecture from the National Physical Laboratory from my one of the room. I'm busy with my lab also, that besides doing the other things like a chairman of National Accreditation Board of Laboratories, then other committees I have got a lot of, then rather Raman Fellow for the Department of Atomic Energy. So in spite of that, I don't leave my lab. I work in lab. I believe that I must devote at least 16 hours a day. Otherwise, I feel uncomfortable to work. But you need not to worry on that part that you feel that I am asking you to do for that much. You may be better, you may be more intelligent, you can put a 14 hours, but it needs a lot of time to do. And no holiday. Now the problem comes that I initiated my career from the solar cell, silicon solar cell. And we know all, I was also very, that time feeling pride of that I'm working on such a device. No one was working in India. I did everything from India. And then the idea was that I'll try to get something better, solar cell. So I published the papers on that. Even today I do that. But the point is, I could not make a big dent on the solar cell because I wanted something new. What I did, I initiated my work, I diverted myself towards the other work. And it is a final, I'll say that in this invention, which is considered as the biggest invention of the 21st century on green energy. I could not, say that it was only the solar cell experience. Of course, it helped me a lot when I started working for something new with the new ideas. That is what is needed. But besides that, actively what I was doing, I'm just reading I'll not get into the detail, but you will understand that if in so many materials, if I work, then I kept on gaining some experience. Of course, my students were doing PhD. I had different projects, national projects, international projects on them in India, sitting in India. But the point is that what I am learning out of them, I should be able to come out with something new, which I could get into the my this hydroelectric cell. So I have put here first because this industrial metrology and national standards on magnetism. So this is for the industry, what we are serving to the industry. Because what happens, we sometimes don't feel that for the industry what we are doing. You are doing a pure research, and that R&D is not going to help. So industrial metrology and national standard on magnetism, I could establish for the first time in India, which was not existing. Then I started working on strontium ferromolybdenum oxide as colossal magnetoresistive material. And here also 3-4 students have done the PhD. Then I also worked on the spin Hall effect, which is, frontier area work. Even the CMR material, it was also frontier area. And spin Hall effect is a quantum rich, heavily classical, not the classical mechanics, but this this was the spin Hall effect also. I could produce the student and as well as the papers on it. So magnesium ferrite as humidity sensor and hydrocell energy. I have kept it because Dr. Jyoti Saab was working as my PhD student way back 12, 14 years before. So as a magnesium ferrite as humidity sensor, that was a start with, because humidity sensor, I'll explain you in my coming lecture, that the humidity sensor PhD she did on it, and that only gave me a lead because I was thinking that how the water, like in a solar cell, um, the sunlight we are using from the sunlight is free and the people are. So the idea was, but there was a limitation where the sun is there and then only it can work. And solar cell is a very expensive process to produce. It needs a lot of capital equipment. So I thought we should have something very simple. So magnesium ferrite on a humidity sensor, then we move towards, based on that results, we move towards the hydroelectric cell invention. Then during this time, we were doing lithium ferrite, polymer composite as microwave absorptive material. I have a lot of work in barium titanate, lithium ferrite, composite, and gallium ferrite. More than 200 papers are only on the multiferrite compound, because that also gave me a lot of insight between the different material. Then nano zinc oxide as a dilute magnetic semiconductor material. This also I worked. Nano zinc, ferrite, cobalt ferrite, nickel ferrite by microemulsion method. You can see that I'm talking about not only this, the process of the preparation of the method. So I learned, even being a physicist, and I was working on the device. So microemulsion method I learned way back in 2003 to work for my nanoscience, nanoparticle of our ferrites. Thin film by RS sputtering and pulse laser deposition facility. I have not spoken here thermal deposition because all these facility I created in my lab, and we could publish the good papers even on the thin film. So it is earlier one, most of them were the bulk. If I talk about ferrite, even the hydrocell I talk about. So all these were our normal solid state reaction method and some chemical method. But when I thought there must be some device for them. So the thin film is very, I'll say, the necessary for that application. So RS sputtering, pulse laser deposition, and all are integrated at home. It is not that here also we purchase the laser from the outside, but the all vacuum system here, So it's a, creating the facility, creating the integrated method for measurement also, which was not available internationally in case of whether CMR material or spin-Hall effect, all were created in the lab. Key measurement. And that gave me a lot of insight. And so is the case with the Dr. Jyotisa, who is working with me for last 17 years, 18 years. So she also learned a lot. And then my other team members, students. And here the silicon solar cell fabrication and technology development. Silicon solar cell fabrication and technology we had given to Central Electronics Limited way back in 1985-88. Right. So you can imagine it was a group. I was one of the key member to this. The point was working on it, then translating into the some form, but it should come out something new. How to come out? In this, I have not written about the. I was working on the hydrogen superconductivity. Then there's some other optical thin films. So because those have been for a smaller period, like 3 years or 2 years, and these have been overlapping the 3, 3, 4 activities once. So what I could see that this was my total strength from where I could learn more and more and do it. Then the again comes the when we do something, whatever in the science, so do we get some international recognition? So already he has taught. So fellow of let's say IGU, National Academy of Sciences, outstanding academician of Asia Pacific Academy of Materials, associate editor, already Dr. Manoranjan has spoken, General Applied Physics, associate editor of the UK, which it is on the measurement and nano. So I am here for last 8 years, associate editor, General Physics Pramana. Here also I worked for the 7 years, So these are the some of them, but a handbook on magnetic materials in 2015 by Elsewhere contributed chapter on ferrites nanomaterials to spintronics. So you can imagine that it was the I was given a invitation in 2014. So that time I got an invitation for doing this. A series volume chapter on magnetic materials contributed hydroelectric cell and alternative to solar cell and fuel cell for masses. It's already published in this volume. A conventional energy system, volume 2, edited by I. Denser and February 2018 elsewhere. So the hydrogen cell could get space this one nanomaterial, spintronics, magnetic ferrites, this I had been working for 20 years and then I could get a chance to get into my Elsewhere's handbook, right? Invitation. You will see there rarely some Indians are there, right? Who are working even in not in India. Same is the here, magnetic material contributed hydrogen cell an alternative to solar cell for masses. So in 2018 and in 2018 itself, we had we were honored by the Renewable Energy Award, India Award. So it is the national, one of the best award on the this renewable energy systems. And I was basically honored by Office of Naval Research, Washington, USA, for my work on multiferrites for the electromagnetic sensor with Italy group. And they awarded me $0.1 million US as a contract project in 2011. So everybody knows it's a crown project of the ONR, but everything sitting over here, doing here, right? Papers published in PRL, Engevandi Chemi, PRV, JMC, ACS, JPC, sensor actuator. You talk about International Journal of Hydrogen Energy, solar cell, APL. So that shows your strength, that what exactly you have been doing. So for our young researcher, I thought why not to just tell you about the Raman effect versus hydroelectric cell. Because this question was asked to me in a very big international platform. So Raman effect, when I talk, it is a physical phenomena observed in molecules with changeable polarizability. It is a device which generates green energy with an exceptional combination of material science, oxygen deficiency, nanoscience, and electrochemistry by water splitting. I also sometimes think back that the three interdisciplinary sciences have been merged into one to give this. While I was working with the solar cell, it was simple P plus N plus structure on the our silicon as a solar cell. Now, when we come to the water splitting, and here this changeable polarizability, it was discovered by C.V. Raman and Sir C.V. Raman and Dr. K. Krishnan in 1928. Invented by Dr. Kotnala, Dr. Lisa in 2000, initially in India. Found significant application in structural fingerprinting of molecules. We know very well how important Raman effect has come after 1990. So fingerprint for the molecules. Earlier, the spectroscope was, not so much powerful. The people are working on it. So we write here great significance in today's scenario for sustainable environment and green energy crisis. The important is the again another part. The pre-existing theory was validated by the discovery of Raman. That is why the Raman effect was said to be discovery, because theory was already given on this, on which the Sir C.V. Raman worked. In our case, no. The invention has created a big buzz and its wide acceptance by international scientific community through the publication of Hydroelectric cell in highly reputed journals, book chapters, and news covered globally. And moreover, we have got a prototype. So you can see the videos in YouTube, but also if you get a chance to come to National Physical Laboratory, you can come and see the prototype, how it is working, how it is giving generating hydrogen, how it is generating the electricity, and you will see its small application, which we could make possible in lab. The Raman effect was quickly recognized by other international scientists as a brilliant and surprising discovery. So, that was quickly recognized by the surprising discovery, because there were that kind of a thing, because Sir C.V. Raman went to the England for some measurement and other things. But anyway, that's the one of the biggest contribution he has made. And now hydroelectric cell has come for the energy sector. Then next question comes that why the need of green energy? Reason is very simple, that CO2 emission by electricity generation in 2020 was 0.5 kilogram per kilowatt, because CO2 emission, in which 35% share was from coal. Because the whatever the carbon dioxide is being emitted, so that has been by our coal, because the coal plants were being used in it for the mainly electricity generation in not only in India, it is even the US, it is in other countries, and also in India we were producing 35%, and that CO2 we know very well, it's the greenhouse gas also. So it is increasing the temperature of our environment. 28% of CO2 emission comes from renewable energy sources also. Now, again, while we talk about the CO2 in the previous slide I have spoken, but here you will find that 28% share of CO2 emission comes from renewable energy sources. Now the question is why and how, right? Because it has been hydroelectric dam has been taken into consideration, that it also not only cutting the trees and how much we are losing and how much CO2 emission it is going to give us for the other purposes. For the solar cell, something is given for the biomass, because biomass has been also considered as a renewable energy source. So biomass is also being used in the Europe, particularly Germany and France. So then is the wind energy. So all this week, it has been already calculated 28% share of this. But interestingly, 9% of the CO2 emission comes from photovoltaic, solar cell and windmill, which we at the moment consider it to be a completely nil, but we are basically computing the carbon footprint from any of the process or any of the energy system is being used. So it has been found, and this is the old data. Nowadays, there are a lot of other things are being added to it. Other kinds of I'll say the accessories are being added. So it is further increasing. So it is not that the photovoltaic is not giving us the CO2. Now it is a known to us electricity generation contributing the highest carbon dioxide emission significantly, evidenced by the global warming effects. It's a completely drought situation. It's the heavy rains, the glacier melting, and fire in forest. So this has been the one of the most important CO2 emissions significantly by the global warming effects. And our automotive industry is also the very, I'll say, responsible for this. It makes a big sense that there is no planet B. We need to save our planet. That means urgent need of cost-effective, sustainable, clean and green energy technology to tackle climate change by near zero emission of CO2. And you would have seen that nowadays on the top level COP26 talks of the zero carbon, not even carbon dioxide, they talk carbon, zero carbon, net zero carbon. You want to do it. So if it is to be done, so we have to make a different efforts. Then the next, it comes as a urgent need of cost-effective, clean and green energy technology to tackle climate change by near zero emission of CO2. So the answer was solar, wind, and hydroelectric dams are have been there, but they are costly affairs also. Even the windmills in India are not working very well. Clean energy is the most important source to keep environment clean. So 21st century invention of hydroelectric cell. So it has been put into a just easy understanding that the how you will find Volta cell was invented in 1800, 1800, dry cell in 1886. Till today, we don't have any replacement of it. So you just imagine that we have already 140 years more than and we are using. Okay. Lead acid battery invented in 1859. Prior to that. And still we have been using lithium ion has taken some portion of it. But again, we all know that how it's not only carcinogenic, it's not health-wise, health hazards, other problems. Solar cell invented in 1954. From if we look at the 18th century and then 20th century and the 19th century, we find the things have not come up to that level. Lithium ion battery invented in 1970. Hydroelectric cell invented in 2000. Lithium ion battery is a secondary battery. So there is a loss. It is to be charged. In case of hydroelectric cell, no loss because it's a primary source of the light. So if you look at from here, you can see that how Volta cell, then the solar cell and this lithium ion battery, and now the hydroelectric cell. It's a schematic diagram of the hydroelectric cell, how it looks. And it has got at initial stage, the small applications, lighting, then mobile phone charging, even the drone, because it's a lightweight. It is not a heavyweight. Then coming to how it works, and particularly hydroelectric cell works. So it has been simply shown in the small schematic diagram that the anode is here, cathode is here, water is coming up. Then this material, our oxide material, is dissociating it, which is the oxide material is oxygen deficient and nanoporous, 30% nanoporous. So then it will produce the electricity on this. So now prototype cells energizing 3-watt bulb and LEDs. So what we have done for this 3-watt bulb in the lab, we have already tested for 600 hours working. Now, of course, some maintenance is in between needed while we are using because we are in the beginning of this. And you can see the original hydroelectric cells here. And these are the new type of the solar cell, which are the tin oxide based cell. You can see the light of this. And again, this tin oxide, a lamp of which is having a 32 LEDs is lit by this one. This you can see the small size. It is on the paper. There you can see the font size of that one. And also those three small we have put like a button cells from the hydrogen cell, and we energize a dia, means in which LED is there. You can see the illuminant, and we did it because once we put the few drops into the water here, it runs for at least 14-16 hours. And cell size, you can imagine, it's a normal size of the dia. So now this is I have given here the company system volume book. What is it? Ali Award 2018, US patent, and the particularly the material which were, very important, sensor actuator, 5 papers which had given us a foundation for our this material to develop. You can see that which were published way back in 2007, 2018, and we kept on moving on this ahead like a hydroelectric cell alternative to solar cell and fuel cell. Why? I have already explained you the difference. Now, when we talk about hydraulic cell itself, can we talk its salient features? Yes. Green energy source made in India, novel and environment friendly technique, no toxicity on disposal. Because let's say today I even replace the small dry cell, and then you know that with the dry cell how much e-waste toxicity is there, and that runs only for the very small time, depending on its power uses. But if hydrolysis cell is being done, which normally we put with a small water, it even today works for the 3 times than that, and the price is almost near to the same of the dry cell. And what is happening with this? We use it and throw. Zinc is a biocompatible. Silver is a biocompatible. We are not using anything on it. Which we are using magnesium ferrite on it, which is a magnesium oxide, iron oxide, and also lithium oxide. So all these are just getting mixed on the earth and water, and they do not have any adverse effects on our health. So what is happening to it? All indigenous equipment used in the fabrication of hydrogen cell, useful byproducts, which I have already spoken, hydrogen gas for clean energy, zinc hydroxide nanoparticles. No external energy is used, facile, cost effective, of course, environment friendly, portable, easy to carry because it has a very less weight. High potential to replace solar cell and fuel cell, no acid, no alkali, only few drops of water needed to run the device, and it's a primary source. Then what could be the preeminent hydrogen cell strategical application? So I have already spoken to you. So this has been shown that how we can even, there's no need for the charging of battery, because once we use, because this is in our lab, we have already put in a one box. These are the hydroelectric cell, magnesium ferrite based, and they are connected in series and parallel depending on this. And you can just with you have a system for putting the water into it, and you can get the electricity out of it. So that batteries will be working on this. The next question comes as because whosoever are doing it gives the flavor of the importance, and in the Indian context, in the international context, that what it is. So I'll quickly go with it. I'll not take a longer time. Processing and characterization of lithium magnesium ferrite is a very simple. Where you can see lithium carbonate, magnesium carbonate, iron oxide, mixing and grinding. Then that powder is put for the pre-sintering. This is normally we are putting around 800 degrees C temperature for 4 hours. Similarly, the grinding and pelletization. Now once the pre-sintered powder has been obtained, we prepare. These are the original um, uh, print photographs of our cells, 2-inch die, 2 cells. And actual this is a pellet and on which the electroding has been done. So it is another picture of this. So but this picture will come later, because first we have put as the pellet, grinding and pelletization, and then we go for sintering. Sintering is done for the level of our temperature is 1000 degrees C. Uh, for we do it for 2 hours or 4 hours, and then we work for it as the silver electrode putting, that we are doing by a simple um, screen printing method, and the zinc foil is put on the back of it. So it comes out to be a very simple, and then you get a hydroelectric cells. And it is, in any of the lab with a very little investment, very little, I'll call. In fact, the 2-3 students can even a pool, and they can buy all these small equipments to work on it. But the point is, when I had to look for the most oxygen deficient lattice, I wanted to know that, because I have told you that it is a material which is oxygen deficient and nanoporous. So what is the particle size, how the Moire fringes are there with the strain developed if we are substituting by something, and then you can see that how the material is showing us the lattice about it. That is the work which was shown to give us the idea that what kind of surface we have, which planes are available on the top, what I'm talking about. Then similarly, what we did without the water, when we go for the impedance spectroscopy, what we find with the real impedance is here, imaginary impedance here, and the impedance is of the order of 10 power 7 ohm. Means you can just imagine 10 mega ohm an hour. But when we put a water, HEC in water, then we look at this is the impedance of our now material. But when we enlarge it, we find that it has the 2 tails. So high frequency tail, low frequency tail is there, which are indicating that our H plus ion presence and OH ion, because otherwise 2 different ions have got the different mass, so their frequencies are different. So it gives this idea. Similarly, nanopores in magnesium ferrite, one can see here transversely how long is our nanopore. Nanopore size varies from 20 nanometer till the 50 nanometer, and then even 100 in some cases nanometer, and the length of it is happening from 100 to 200.
Okay, Prasad.
Similarly, we wanted to see that how much will be the porosity into it. So that porosity has been done by the BET surface area, and one can see that it is 165 meters square per gram. So such a high. It's around 30% porous material. Similarly, surface charge imaging, electrostatic force microscopy, which we had done, EFM, to understand how our H plus ion is present on the surface. So we had applied externally from the conducting probe of a AFM minus 0.6 volt and plus 0.6 volt, so that we can see the contrast in images, and that confirm direct presence of the H plus ion on the surface. Now because that is I have not talked about the science on it more, but one can see that initially we had to do all those kind of measurements. Now we don't need those measurements, because those were the validation measurement for the first paper that the invention has been done. Now they are the very simple ways. You don't need any sophisticated instruments for the measurement. But for the hydroelectric cell comparing with solar cell, parameters, hydroelectric cell, solar cell, output voltage 0.98 volt, output voltage 0.6 volt, current, density, and power density. 25 milliampere per centimeter square, it is a 30 milliampere per centimeter. power is 25 milliwatt, we are getting 18 milliwatt. We are getting 25 milliwatt and it is getting 18. So we had some lower current. Now we have surpassed this also, 30 milliampere. But the point is, our voltage is putting it to the higher power density of this. Availability 24 hours, 365 days for the 100 cell. Solar is 8 hours, 180 days in a year. Capital cost is very low and solar for the solar is very high. Disposal issue after use, disposal hydrocell after usage is biocompatible. A huge electronic and toxic waste we are getting in it. So if we look at hydroelectric cell as a incredible green energy source invention, so it is not only dissociating water molecule, which we have said, but it is also generating our high pure hydrogen gas and zinc hydroxide nanoparticles, which I have been talking about. And this is a schematic diagram, not the original diagram, that how the green hydrogen we are getting out of it. While we talk about the particularly hydrogen gas in achieving net zero emissions, so cleanest fuel that produces only water when burned with oxygen. That is a cleanest fuel, and that what is our hydrogen. Highest energy content calorific value nearly 3 times that of gasoline by weight today, which gasoline we are using. It means the consumption will be 1/3 of the quantity of the hydrogen compared to the gasoline. Commercial hydrogen production generates 830 million ton carbon dioxide each year. Commercial hydrogen production. Expensive and sophisticated techniques for highly pure 99.99% hydrogen gas. It's a very expensive. But if we talk about our hydroelectric cell, it's a reverse mode, means we have to apply a low power, low external power applied. We get a 99.98% hydrogen purity. You can see the simple way, but now we're applying it from outside and these are dipped into the water. And we get the best technique and having a maximum, I'll say the maximum mileage over producing. We have produced hundreds of the liter hydrogen in our lab, but we cannot go beyond that. The reason is very simple. Let's say we need a lot of safety aspects of it. So what we have done, an unsurpassed technology for generating highly pure hydrogen gas by applying low power to hydroelectric cell. Low power. So for the low power, we can use even the solar cell, directly putting it and getting this and storing it. So it can be used for the chemical production, can be used for the fuel gas, can be used for the fertilizer, because the hydrogen is being used for these applications more into it. So that way we have got our lot of advantages over this. So I thank you, all of you, for the kind attention to listen about the new energy device. Thank you very much. Hello.
Yeah, thank you, Professor. Yeah. Yeah, thank you, Professor Kotnala. I would request the audience if they have questions. Sir has already given this freedom that you can ask questions. So
yes,
are there questions? Yeah.
Excuse me, sir.
Yes, please go ahead.
Hello, sir. Yeah, it was mentioned in this hydroelectric fuel cell that, sir, I want to ask the mechanism once again, like how the water is passing upon the medium and how it is converting this H plus and OH minus.
Right. I'll give you a very simple brief about it. What we do that any oxide, but now because I'm talking about most of the time magnesium ferrite, right? But we have done it on 28 oxide compounds already, whether it's SNO2, it's a SiO2 or this. What is happening? Any of these material, I'll call it having oxygen into it, metal oxides, they uh, they are somewhat they have the defects because we are dealing with the not a crystalline but a polycrystalline material which we are doing. So then there is a always some defects into the material itself, and we have specifically chosen magnesium ferrite because it is one of the worst ferrite which has got the very uh, high level of oxygen deficiency because of its structure and as well as the preparation way. So we chose that one. And whenever there is a oxygen deficiency over any of the material, or we create it through the processing, which I have told you that the pre-sintering process in which we do the something more to create more oxygen deficiency. For that we do the doping also. But when we do this, any of the oxygen deficient space which is given, as soon as the water molecule is on the surface of this material, the oxygen deficiency, because our material is most of the time, whether it is a oxide or metal oxide or it is a ferrite, it is a basically a semiconductor material. So then the sum of the electrons at the room temperature are being trapped by the oxygen deficient state. So when that has been done, the water molecule being a polar, once in the oxygen deficiency, there is a electron is trapped. So the water molecule is getting intimate contact with the oxygen vacancy. As soon as it does that, what is happening? The water molecule, because H plus side will come nearer to it from the water side, and the OH ion goes towards the our basically anion. Anion means the metal part of it. That is going to have no cation, sorry, metal ion. So metal ion which is on the surface, you know very well, they have got a dangling bonds. So those dangling bonds will immediately take up the OH ion because they are deficient on that. So OH ion has been taken by in our case, magnesium, iron, right? And when we substitute lithium, so lithium does more quickly. So they immediately take from the water molecule which have been on the surface of the material. So that OH ion is now taken by this one on the surface. But the H plus ion, which is now free, it starts hopping on the surface. So while it hops on the surface, already there are the more water molecules which have been on the surface of the material, means the pallet. So that is the H plus ion is getting into it and it dissociates few more water molecules because the chemi layer is the one single layer. Then there are a few fizzy dissociation layer. It has been calculated 7-8 layers can be there. So H plus ion is moving through that. Means we normally call it a proton or hydronium ion H3O plus. When it happens, so it dissociates, it generates a more electric field between the water molecules absorbed on the surface. So that is also dissociating more molecules. This was given by the people have observed it 80 years before also. But the current when we are trying to collect out of it, it was in the picoampere range. What we did, we modified our material, making it more oxygen deficient and creating 30% nanopores on the surface. If you will be, you would have listened in the beginning that the oxygen deficient and then nanopores. So 30% are the nanopores available on the surface. So H plus ion, which was getting free because OH ion is bound on the surface. Now H plus ion, which is now hopping on the surface, now few of the our H plus ions are getting trapped inside the nanopores, which we have generated so many. And in those nanopores, the electric potential, electric field generated is of the order of 10 power 3 volt per centimeter. And that is now acting as a big source of water dissociation, whichever is coming nearer to it. Because we have put on the surface of water, right? Then the water is further being dissociated by our nanopores electric potential. Then we are getting continuous supply of H plus and OH ion, and from the picoampere to we went to nanoampere getting it because we were improving our material capability on that. From the nanoampere, we went to the microampere. It took us our 7 years to come into it. Then within next 2 years, we could get into the microampere to milliampere. And today we are getting in hundreds of milliampere. So we are changing everything on that side, which has been within nanoporous, and it is our specialty required for the material development that we have to generate the nanopores, and we are not doing any kind of a template or any advanced technique. We have been simply generating it through our solid state reaction method, but the only in which way we have to do it, what processing we have to do it, do we have to work more on it? So that what it is. I think it would have made you clear.
Yes, sir. Thank you.
Thank you. Any further questions? Inquisitiveness,
Sir, excuse me,
any
sir.
kind of guidance? Yeah. Yes. Yes, please.
Sir, good evening, sir. Thank you for your presentation, sir. It was very nice and very informative to us. Actually, sir, I want to ask regarding the, sir, is the efficiency of the hydroelectric cell depends on the particle size or shape of the particle, sir?
When we talk about the efficiency of that, this one that say basically, if we say the efficiency of our hydrocell is to be measured, so that is to be measured with the more dissociation of the water, means water splitting should be more and more, which we have been doing, right? So that is based on the material characteristics, how much um, oxygen efficiency we are able to create, and the size of our nanopores, which is also one of the very important. So these are the points which we know that it is going to help us better. And for that, I have opened up to all young researcher, please work on those aspects which otherwise other people will, out of country, from the foreign, the people will do it. The people are doing it now. They have started working on theoretically on it also. But this what we want, that in increasing efficiency, it's already quite efficient, but still there are the points which I know we have to improve. And here I need the young minds to work. Hello.
Yeah. Tupan, is that fine? Any further question? Tupan, you were asking something.
Yes, yes, sir. Yes, sir. Thank you, sir. Thank you, sir.
Okay, thank you.
So any further questions? If not, then let us thank the speaker for the session. So in online mode, we have this online applaud.
Yes, online.
Yeah, thank you so much, sir. Sir, I had a kind of inquisitiveness, like when we look
Yes.
at the scenario of fossil fuels, right? They are not going to last more than about 50, 60 years if the current consumption rates are going on. Plus the future developments which are in place, like IoT, if we go into, or 5G communication we go into, we are unscrupulously using data, and for that the related infrastructure is going to hog more energy demands.
Yes.
So for such a thing, like such a set of thing, if we want in future a sustainable growth, Like we should also not shy away from these growth possibilities. So these decentralized or maybe off-grid solutions are going to be an option. Like people would like to look at that. So over here, like you had talked about this non-photocatalytic cells, right? So like is there a possibility that sunlight tapping sunlight through these kind of water splitting also has a future?
Yes, it has also future, but the problem is when we say the sunlight,
Mm,
that has limited the scope of even the solar cell.
mm,
That is why the solar cell could not be, taken. Even today, there is a problem of that,
mm.
and all countries do not have the all time the sunlight. So
Right.
the solution has to be like from the how to generate the green hydrogen
Mm, mm,
in which,
mm,
and it should be a clean method also, clean process. It should not be like from the petroleum products and
mm, mm.
the coal, because you know very well the coal gas, producer gas, there we generate the hydrogen also, but it is a very impure and it is a chemically very dirty also and atmospherically wrong. So the solution should be like a as we have done this part as I have said, and whatever I have said, these are the known facts and already published one. As I have said, there are many papers we have published only on hydroelectric cell. That this kind of a some other material which can be taken up for the hydrogen production. So here we have already developed for this also uh, for the hydrogen generation and electricity generation both. So if we get, let us say, something, some battery, even which is secondary source now I'm talking about, which is a completely biocompatible and environment friendly, that will also help us a lot because you know this. But otherwise, what I perceive and what I see, foresee, that the hydroelectric cell, if we are working, because it has all those potentials. By the way, if you, I do not know when you will get the time or something, you can interact with me also, or can see in the lab. It has got an immense potential to at least remove those electronic waste uh, and toxic waste, e-waste I'm talking about. So that can be removed easily. And then there can be a combination of solar cell, some wind energy where wind is there, right? And the hydroelectric cell will take most of the our small applications, bigger application with the time we can go for it.
Okay, thank you, sir. No, because I was also trying to explore some additional options. So over the last 5, 6 years, like my group has been trying to figure out biomass as a possible ecosystem around which things could be running. So besides that, like this hydroelectric cell also, as you have motivated, like that is kind of one of the promising options, because until and unless something that we are generating at a perennial level, like we cannot depend on fossil fuels forever. Any waste or anything which is generated annually, that is still a good resource of energy, say municipal solid waste or biomass, agricultural biomass, they're still tappable. Like of course hydroelectric cell that you showed seems to be having the biggest potential among all these candidates.
Yes,
So yeah,
you are right. But the even for the biomass, we have a a lot of the I'll say the CO2 emission and the control. So if it is
mm.
controlled, then it will be very very useful for that purpose. But we have to find the way out.
So
That
basically
is why.
hydrogen enrichment, if we go through hydrogen enrichment for biomass, like so whatever syngas is produced, if we go through a process of hydrogen enrichment and carbon sequestration in the process, like that would be one way forward. Because we
Correct.
addressed one of the issues with biomass, that was like people were using direct burning.
Mm.
And we proposed that okay, we'll go and gasify it and use syngas, but not suffer with the same limitation of a century old paradigm that as soon as we do gasification, the efficiency drops by half. So instead of about 48% direct burning, we go to an efficiency of about 24%. So primary reason we found over there was this loss of belly heat. So in any gasifier, this thermochemical reaction would take place in a region, and if we call that a belly, so heat would simply escape from that to
Yes.
environment. So we made like suitable heat exchangers that will preheat the fluid, and then later on we heat the fluid by suitable burners running syngas. So and then we use hot water as a source of energy, like
Yes.
say for desorption cycle,
Mhm.
and so create refrigeration. So the whole idea of this task has been to make cold storages
Correct.
using
There it
biomass,
can be
so
very useful.
agricultural
Yes.
waste. And but then like this was only solving part of the problem, like we were not really generating power, so to say. The other area where I had a personal interest was on thermoelectric materials. So there also a very, that is also a 1% or a 5% technology. Like it does not really do. So I'm really excited to know about hydroelectric cells. Like
Oh,
particularly some of the work in complex oxides could be done, maybe Dion Jacobson phase or like some higher Rudolfson Popper, where we have the right kind of parameters to make it more efficient. As you said that you
yes,
want
yes,
to
right.
want more people to get into this. So
Correct.
I would really read up and then get back to you for more advice. Yeah.
No
Thank
problem.
you,
That
sir.
will be.
Thank you.
Uh,
Yeah.
thank you very much. Uh,
So, Dr. Kerr, you would like to ask something, or yeah, it's also
No, no, it's
late in the evening, and professor would be, yeah.
no, no, it's all right. It's all right already.
he knows a lot about the hydroelectrics already. Uh,
Yes.
he's working on that also. He's some of the student is doing. So the I don't know whether he has some question. Always I'm open on phone, on mail to
It's
anyone. Of
okay.
course, not only that. With him is a special with the Dr. Kar, but for with you also for to Dr. Thakur also we can get into the more interaction and things will be more clear.
And I'm sure the participants, teachers from various colleges, they would have gotten some very useful insights, and some of them will get going into maybe solving some of these problems, right? Also
Right.
joining the kind of efforts. Thank you so much, Professor Kotnala. It
Okay,
has been
thank you very
really
much.
great having you. And we would like to, we had seen you earlier on campus. I'm really
Oh,
very shy to approach and talk, so I
oh,
did not approach you at that time.
which
So
campus?
next time when you visit, so you visited like here, right? Our
Where?
campus about
No, which
like
campus?
last time, our IIT Patna campus.
अच्छा, अच्छा,
Right,
that time.
you visited when
Right.
Professor Carr invited you, right? At
Uh,
the time, I was
right.
really hesitant approaching and uh,
Okay.
talking out. Yeah.
So no
Yeah.
problem. We can again meet and we can.
Yeah.
Now there's no shyness in between us, so we can move and work on.
Right. Right.
Okay,
Okay.
right. Thank
Thank
you
you,
very
sir.
much. Okay,
Thank you,
good
sir,
night.
for
Thank you,
your
sir.
time. Yeah.
Good night.
Yeah.
Sir,
Thank you to
thank you
all.
very much for your
Right.
yes.
Okay, thank you.
Thank you, sir. So, Professor Carr, maybe you will stay back for a few minutes for like we have to
Yeah.
discuss few things with the candidate participants. So first of all, there is a Google form that they have to submit based on today's discussion, like today's talk. So this is only for the FDP participants. I can see there are a couple of PhD students also from IIT Patna in the group. So it is nice like when jab gyan आ रहा है तो it is nice to attend and soak as much. Okay, so this is the form. Yeah. So I would expect every FDP participant to fill. There are two questions related to today's talk. So please try to answer. This is just to make sure, like, if there are the key ideas were understood. So you can fill and submit. And it is my earnest request that please try to attend the offline sessions also. If you can accommodate that, if you need, say, referral letters or something requesting your institution or something, we can try to pitch in. But please attend. AICT officials actually told us that like while they are approving or while they are allowing teachers from various parts of the country to participate in these FDP programs, they are not levying any registration charges or any such thing. So they are trying hard to make sure that the dynamics of science and technology within our country improves via more interaction. It's not like you only will learn from us. It is we also learn from all of you. So like please try to take part in the offline session also if it is allowable, right, from your schedule, because a lot of you are saying that there's one reason or other. So there will always be reasons to avoid something, but there has to be one reason to do it. And that reason would be we really want our country to be a developed nation, right? And we want to contribute in a positive way. So these hands-on sessions and this lab exercises and interaction sessions which are planned, um, we really look forward to seeing you attend all of that. Thank you. So, Dr.